Hello everyone, and welcome back to the channel. In today's video, we're going to explore two very important concepts in Linux storage management. Linux file systems and logical volume manager, commonly known as LVM. These topics are essential for Linux administrators, system engineers, DevOps engineers, cloud engineers, and anyone preparing for Linux certifications. By the end of this video, you'll understand what a Linux file system is, common Linux file systems and their use cases, traditional Linux storage architecture, what LVM is and why it is important, how to create and manage LVM storage, how to extend storage online without downtime. So let's get started. What is a file system? Before we can store any data on a disk, Linux needs a way to organize and manage that data. This is where a file system comes in. A file system is the method Linux uses to organize, store, and retrieve data on storage devices such as hard disks and SSDs. Without a file system, the operating system would have no way of knowing where files are located or how to access them. Think of a file system as a library management system. Just as a library organizes books so they can be easily found, a file system organizes data so the operating system can quickly locate and access files. A Linux file system is responsible for managing file names, controlling permissions, managing file ownership, organizing directory structures, tracking where data is stored on disk. In Linux, everything starts from a single root directory represented by a // All files and directories branch out from this root directory. Common Linux file systems. Linux supports several file systems, each designed for different use cases. Let's look at the most common ones. Extension 4. Extension 4 stands for Fourth Extended File System. It is the most widely used Linux file system today. Advantages include stability, reliability, excellent performance, broad support across Linux distributions. To create an extension 4 file system, mkfs.ext4/dev/sdb1. XFS. XFS is a high-performance file system designed for enterprise workloads. It is especially suitable for large files, large storage systems, high-performance servers. XFS is commonly used in Red Hat Enterprise Linux and its derivatives. To create an XFS file system, mkfs.xfs/dev/sdb1. Btrfs. Btrfs is a modern Linux file system that includes advanced storage features. Features include snapshots, compression, data integrity checks, storage pooling. ZFS. ZFS combines a file system and volume management system into a single solution. Advantages include excellent data integrity, built-in snapshots, storage pooling, advanced enterprise features. Now we discuss about traditional Linux storage workflow. Before LVM became popular, Linux storage was managed using a simple structure. Disk partition file system mount point. Let's see how this works in practice. To check available disks, use command lsblk. Assume a new disk appears as /dev/sdc. To create a file system using the new disk, use command mkfs.ext4/dev/sdc. Now create a mount point by using command dir/data. Mount the created storage now by using command mount/dev/sdc/data. Now verify by using command dfh. To view file system, type command dfht. You should now see the new storage mounted using the extension 4 file system. Although this method works, it has a major limitation. The storage is mounted directly to the operating system. If the disk becomes full, extending or resizing storage can be difficult and may require downtime. This limitation led to the development of LVM. Now we see about LVM. LVM stands for Logical Volume Manager. It is a storage management framework that provides flexibility and scalability for Linux storage. Instead of working directly with physical disks, LVM creates an abstraction layer between storage devices and file systems. With LVM, you can extend storage without downtime, add new disks easily, create storage snapshots, manage storage more efficiently, scale storage as requirements grow. Because of these advantages, LVM is widely used in enterprise Linux environments. Understanding LVM architecture. LVM consists of three main components. Physical volume, PV. A physical volume is a disk or partition prepared for LVM use. Example: pvcreate/dev/sdc. Volume group, VG. A volume group combines one or more physical volumes into a storage pool. Example: create vg_data/dev/sdc. Think of a volume group as a storage container. Logical volume, LV. A logical volume is a virtual disk created from the available space in a volume group. Example: lvcreate l10gn lv_data vg_data. Logical volumes are what users and applications actually use. The complete LVM architecture looks like this. Disk physical volume group logical volume file system mount point. Now we see a videos of practical LVM demonstration. Step 1. Verify the new disk. lsblk or fdisk l. Assume the new disk is /dev/sdc. Step 2. Create a physical volume by using command pvcreate/dev/sdc. Step 3. Create a volume group by using command create vg_data/dev/sdc. Step 4. Create a logical volume by using command lvcreate l10gn lv_data vg_data. This creates a 10 GB logical volume named lv_data. Step 5. Create a file system. For extension, for use command mkfs.ext4/dev/vg_data/lv_data. For XFS, use command mkfs.xfs/dev/vg_data/lv_data. In this demonstration, we will use extension for mkfs.ext4/dev/vg_data/lv_data. Step 6. Mount the logical volume. First, create a directory by using command dir/data, then mount/dev/vg_data/lv_data/data. Now verify by using command dfh. You now have a fully functional LVM-based storage system. After finishing the demonstration, we will discuss why is LVM important. LVM is widely used in enterprise environments because it provides flexibility that traditional storage management cannot offer. Benefits include online storage expansion, easy addition of new disks, snapshot capability for backups, efficient storage management, better scalability. LVM is commonly found in database servers, VMware environments, Kubernetes nodes, cloud platforms, enterprise Linux servers. Now we will see a videos of extending in LVM volume. One of the biggest advantages of LVM is the ability to extend storage without rebuilding the file system. In this demonstration, we will add a new disk, extend a volume group, extend a logical volume, grow the file system online without interrupting production workloads. Step 1. Add a new disk. Let us check if new disk is attached to the Linux server. To verify the new disk if it attached or not, use command lsblk or fdisk l. Assume the new disk appears as /dev/sdd. In step 2, create a physical volume using command pvcreate/dev/sdd. Step 3, extend the volume group using command vgextend vg_data/dev/sdd, where vg_data is the volume group, /dev/sdd is the new physical volume. Now at step 4, extend the logical volume. lvextend l+100g/dev/mapper/vg_data lv_data. Verify. LVS. At the last step, step 5, grow or resize the file system. For XFS, use command XFS_growth/dev/mapper/vg_data lv_data. For extension 4, use command resize 2fs/dev/mapper/vg_data lv_data. Since our file system is extension 4, we use resize 2fs/dev/mapper/vg_data lv_data. Now we can verify the new size by using command dfh. You should now see the increased storage capacity. This is one of the reasons why LVM is heavily used in enterprise environments. Let's quickly recap what we've learned today. We covered the topic: what a Linux file system is. Common Linux file systems such as extension 4, XFS, Btrfs, and ZFS. Traditional Linux storage architecture. What LVM is and why it is important. LVM architecture including PV, VG, and LV. Practical LVM creation and management. Online storage expansion using LVM. Understanding file systems and LVM is a fundamental skill for every Linux professional. Thank you for watching. If you found this video helpful, please like, share, and subscribe to the channel for more Linux, Kubernetes, DevOps, cloud, and infrastructure tutorials. See you in the next video.